Aloha! Green Garden Guy here again. I like to talk soils. Throughout my career as a horticulturalist, which is at least half of my lifespan, I hear a lot from people about soil problems, about what's bad with soils. It's very, very common. Generally speaking, old farmers, they know soil because they work with it, and they know all soil is good in one way or another. Okay, they all vary, but they're all good. But yet the novice gardeners oftentimes cop attitudes about their soils, and they feel their soils are bad. They want to do something with them. They want to replace them. I heard this a lot in Fremont, California, for instance, and I guess it's because we don't know our local histories usually in the areas we live, because Fremont was at one time the only Spanish mission in the system that had a net export of agricultural goods to the rest of the mission system all the way down into Mexico. These guys were providing fruits, vegetables, olives, hides, and so on, meaning that soils in the town of Fremont were exceptional. They were really good, and I never had much trouble growing on them. But I had so many clients that would come into the nursery and go, "Oh, Bill, I got that Fremont soil, and, it's so bad." And I look at them, and I go, "What do you mean?" That's some good dirt, baby. So I'd like to start off by talking about my soil right here, because it's in front of us. So what you see right here in front of you, this is andesol. Andesol is a volcanic ash. That's what this is. Now, as we turn it over, you will see that about the top 12 inches or so, it's pretty much one uniform, homogeneous color. Okay? But we take this off the top, go a little bit deeper. I know you're down there somewhere. Come on. There we go. I see it. Right there. It is. Okay. There we go. All right, so right here, there we go. I have found a layer where the soil is more orange, you see. And so the more orange soil, which you can see the stains on my fingers, right, is deeper and is below most of the carbon. On top, we have a darker looking material, and that's where most of the carbon is, or humus, okay? Whatever organic matter is contained in this soil is pretty much contained within the top 12 inches, right? Now, as you can see from me pounding away on the stuff, it looks a lot like clay, doesn't it? And I have a neighbor up here right next to me who calls this stuff clay. Well, it's not. All right? It's too coarse to be clay, because clay, when you hit it, usually will not bust like this. All right? So it's not clay. It's a rather unusual earth, to tell you the truth, because then what happens to it is, as we dig it up, and you see here how it's nice, crumbly, falls into small pieces, but when we dig it and it fires in the sun, what I get is angular fragments that really pretty much remain this way. They don't come apart. They turn into something that looks a lot like perlite or something. It's a volcanic deposit, and so it does a volcanic thing here. Now my hands are all grubby. And here, for those of you out there on the web that complain bitterly when you see that I have dirt under my fingernails, that's how it happens, okay? I'm a gardener, I'm a farmer. I usually have dirt under my fingernails. Andesol is one of the best soils that you can have in the tropics. In a tropical environment, it doesn't get any better than this decomposed volcanic ash. This is it. There are a lot of features about the soil, and it's why I call it good. I think we're really lucky to have located the acreage that we have because of the type of soil that's laying underneath it. It makes my life much easier. As you see here behind me, the vegetation looks good, right? Yeah, it looks good because of the culture, because of the way we're treating it, what we're growing, and because of the soil. All soils have pluses and minuses. There is no such thing as a perfect soil. But all soils are good. Sounds strange, right? Well, in this case, for instance, andesol, as you saw with the shovel, it digs easily. Well, that's one feature. Soil that's hard to dig is not fun to work with. So this is an easy soil to dig up. I like that. It's easy to work with. As you noticed, it crumbles. And even though we get a lot of rain here, and even though when you dig this soil up, it looks a lot like clay, even when it's wet, if you hit it, it falls apart. Okay, so that's why you know it's andesol and it's not clay. Because at the macro level, not being able to see the microscopic particles, they tend to look a lot the same. Clay and andesol are similar soils in their look. And andesol does eventually turn into clay if it's old enough. It will continue to break down and finally become little enough to become a clay particle. Right now, the particles are too big and they won't clump together, and they don't do any colloidal bonding or ionic bonding, rather. So the soil falls apart even when it's wet. In a climate where it rains, like we have here, with 150 inches a year, that is if the ocean ever cools off, it's nice to have a soil that you can work when it's wet, because it's always wet. And if we couldn't work it when it was wet, we'd really be in trouble. Now, of course, it's a good soil too, because there are so many people here in Hawaii who don't have soil. A lot of people on hard rock, a lot of people on pohoi lava. Now, these are all growable things. You can grow coffee on you know, you can grow a lot of fruit crops on lava soils. It's not impossible to work with them. Well, they aren't good for row crops, let's put it that way. If you want to grow corn, it's just not going to work out. Most people who have the lava rock soils here who do grow vegetables, you know, they have to build mounds of stuff. They put down cinder, they put down compost, you know, build it up on top, and then grow their crops above the lava, which does work. You see plenty of it here. Okay, but it's terraforming. Basically, they are having to build brand new soils from scratch. Right? Well, so that's another point in favor. 1, 2, 3 here. The soil is easy to dig. The soil works when it's wet. And the soil here is good because it's soil. Just plain soil in Hawaii is a good thing. Now, it has some other positive features, you know, because it drains really fast, which is weird because it doesn't really look like it would. But man, this stuff drains like sand. You have to be standing here to believe this, but we can get 6 foot of rain can come in a matter of days. I can have flood down by the road with my taro underwater. 2 hours after the storm's gone, the water disappears. The soil percolates like crazy. Percolation is a good thing because soils that hold too much water and won't drain out will rot your plants away. So that's a good thing. On the other hand, when it gets dry here, the soil does percolate like sand, and it can get pretty drouthy. We haven't had much rain for the entire month. April was the last time there was rain worth talking about, and I have cracks back here. There are cracks forming on the surface already because the soil's drying out. Well, that's a bad thing and a good thing. So it's double-edged, right? Negative aspects are because not so much the soil, but the local weather system is what causes me problems. Because this soil perks really well, which is a good feature ordinarily, but we get so much rain, my soil doesn't hold on to nutrients very well. And so the rain that comes in huge volumes sometimes here will flush everything down to the middle of the island. This is the only environment I have ever lived in where all fertilizer goes on the surface. You don't try digging it in here, because if you dig it in, it goes below the plants before the plants can reach it. The rains will just wash it to the middle of the island. So, that's my biggest negative. Plus, sometimes, because the soil does hold water too, I have problems with certain plants in this soil that will rot. And so, for instance, papayas, I have to plant them high. If I plant them low, they tend to rot away quickly. Okay, so enough about my soil. Let's talk about yours. Soils in your garden will generally break down into three basic categories. You have soils that are based predominantly on clay. You have soils based on silt, and you have soils based on sand. Now there are a fourth and a fifth basic soil which you likely don't have, but some of you may be gardening on peat, which is a complete organic deposit built up usually in wetlands. You may also, if you live here in Puna, you may have oolithic soils. I call them oolithic ooze. They're soils that have accumulated, I say, either on top of very dense clays, or in this case here on pahoehoe lavas, or lavas, where you get a lot of tree debris falling and the working of roots and plants and all this that decompose into basically kind of a peat-like material laying above, a harder surface. You see them in the mainland on top of dense clays, sometimes in wet forests. You see them sometimes here constantly, actually, on top of the lava. People say, "Oh, I got soil." Well, they're talking about a little bit of oolithic soil that's accumulated over the top of the rock. Other than that, most soils, again, are based on sand, silt, or clay. And in that order, sand is the biggest particle in the gardener's universe, other than a rock, and clay is the finest particle in the gardener's universe. Kind of the easiest way to look at the universe of soils. Silt is somewhere in between. And since silt is somewhere in between, the most desirable soils you can find have a fairly high percentage of silt. Soils that have too much sand, generally drouthy, they drain so fast, they don't hold nutrients very well either. Sand soils, they're real easy to dig, and you can dig them anytime you want to. It doesn't matter, as long as they're not frozen solid. Sand soils can be worked, but they won't hold nutrients or moisture very well, and so too much sand in a soil is a real negative. The clay soils are the absolute other end of the spectrum, and the clay soil, again being the finest particle that there is, they become quite compacted. And so the little particles actually will even develop electrical ionic type bondings that will make them stay together, And so they become rather dense, and they can be problematic. Now, a clay soil, when the moisture is perfect, is really easy to work. And this is something apparently is not well known by the novice gardener. So I would like to impart this. The information came to me from one of the oldest farmers I ever knew, Hank, who died at 98 years of age, and he worked on red adobe soils in Wisconsin most of his life. And he, again, would swear by them, which is the soil that most gardeners swear at. Hank loved that red adobe. And it holds moisture, it holds nutrients, and all you got to do is know when can you turn it, because if it's too dry, the clay becomes like a brick. If it's too wet, it all sticks together, and then when it dries, it turns into big clods, and it's hard to break them down. It's basically fire to bricks in the sun. But when it's in between, when the moisture content is perfect, clay turns like peanut butter. It's really easy. I used to tell folks in California that had clay soils, and they're trying to dig them in high summer. And the guy coming, do you have a jackhammer? Do you have a pickaxe? What for? What are you doing? He says, I'm trying to plant a tree. Well, have you considered using water? Because if you irrigate the clay soil during a summer drought, if you put enough water down in the local area where you want to work, and then walk away and wait 24 to 48 hours until the water soaks in really well, then you just go out there with a shovel and you dig it right up. You don't need a jackhammer. The water will loosen it up. Universal solvent. Works in clay soils. It's got to be just right, though. Somewhere right in between. So you have to be rather skilled at judging the moisture content in clay to know when to work it. And that's why farmers can enjoy, and farmers will love clay, but gardeners don't. It's a matter of understanding that material. The silt sits in between as far as the particle size, all right? And nobody had, well, few of us have all sand or all silt or all clay. Most soils are combinations of all three, plus organic matter. But a silt soil tends to be that medium-sized particle. It's rather workable under a wide range of moisture conditions. It digs pretty easy because the silt doesn't compact bad. Now, if you have just the right amount of sand with silt, what you end up with is a sandy loam. And a sandy loam is, I guess I'd have to admit, it's my favorite soil. I've had a few over the years in places I've lived, some really high quality ones back in the Midwest in places. And a sandy loam is nice because if it's got enough silt in it, enough organic matter, it'll dig really easily. It drains really easily, so nothing rots in it. Potatoes get really big, onions get really big because the soil moves. Great for carrots, you know. Root crops are wonderful in sandy loam soils. They don't get cramped. You know, it'll hold nutrients pretty well too if the rainfall isn't too high. You can test your soil without needing any rocket science. If you just dig up a bunch of the soil, stick it into a canning jar, fill the rest of the jar up with water, shake it up till you got a jar full of liquid mud soup, and then set it someplace. Just let it filter out. Eventually the particles will settle. They will settle in layers. And so rocks and gravel or sand will move to the bottom of the jar and create a layer of coarse materials. They're going to fall out first because they're heavier. The next material to fall out of suspension will be the silt. And so you'll get this layer above the sand that you can read. And you can do this like a percentage. I mean, you want to put a ruler up next to it and figure out what percent you can. The clay will be the last layer that settles out. It stays in suspension sometimes for a long time in water before it falls out. But the clay will be the finest particle and the last one to settle. And so you will get this stratification in a jar. And you can tell, what do you got? You know, what's the percentages? You know, and if you got a whole lot of silt, a fair amount of sand, and a little bit of clay, you got a wonderful soil. If you got mostly sand, and just a little bit of silt or clay, you got a, well, better than nothing, but your soil's not quite as good. If what you come up with is a jar full of sand with a layer of clay, well, you got a brick. That's what a brick is. Yeah, I've had people say, well, I got clay soil, I want to add sand to it. Well, I said, well, you know what that makes, don't you? You know, sand and clay mixed together and fired is a brick. And so it's not necessarily the right thing. If you have an excessive amount of clay, the best materials you can use are things like organic matter. Use compost, you know. Cover crops, turn cover crops in, get organic matter into that clay. That's what it needs. And the more organic matter you have in clay, the better the clay is going to react. When it comes to soils, frequently I have seen people who want to try to replace the soils. This is so common. It really is. It's almost scary. And I mean, I tell you some real horror stories that have come from people wanting to replace their soils, thinking they can make better ones. Well, to begin with, your soil exists deeply to the bedrock sometimes, or at least to some layer in there. It's a deep deposit. And when you start trying to change it on the surface, you know, you're not going to get much effect. Not really, because the basic parent material is huge, and whatever you apply is minuscule. That's really the best way to see it. When you're applying materials to soils, the best place, always, I don't care what kind of soil where you live, the best place is on top. In nature, that's where almost everything ends up. It's part of the natural cycle of how nature works. And I have seen people who have a heavy adobe clay soil wanting to plant trees in the yard, and they decide, well, this soil is terrible, the tree's not going to grow in it, which is wrong. Trees tend to grow in clay pretty well. But they'll excavate huge holes, all right, and then take the holes and fill them with like redwood compost. I used to sell bales of compost. And so they just dig out, you know, and then fill that whole hole in the adobe with redwood compost, and then take like a 15-gallon ginkgo tree and plant it in there, and think, oh, I did this. In fact, I'll fix that clay. That clay ain't gonna trouble me no more. Well, what happens is that when you take organic matter and you put it below the aerobic zone, that's how far into the soil the atmosphere moves, where the air goes. All right. If you get below the aerobic zone with organic matter, when it begins to decompose, when it gets wet and begins to rot, it rots anaerobically. All right. Well, anaerobic decomposition of organic matter is basically what happens in a sewer. And so you develop hydrogen sulfide and methane, both of which are very toxic to plant material. And I actually had the guy who did this bring me back these beautiful big 15-gallon ginkgo trees that he planted because they were all failing. And when I took them and looked at the root ball and took one sniff, it was like, whoa, dude, you got a leaky septic field or something? This is sewage. No, I dug a hole, filled it with compost. Going, oh, you had a hole in clay soil. Yeah. Well, then we got a good winter rain. Plus, then he irrigated the crap out of it when he saw the trees were doing well. And so he flooded them. Well, when you dig a deep hole in clay and you fill it with organic matter, basically what you have is a lake, because the water won't drain out, that's filled with organic matter. The top 2 to 4 inches stays in the aerobic zone. Everything below that goes anaerobic, and it started generating all this methane and hydrogen sulfide. Hydrogen sulfide is lethal to almost any form of life except for a few bacteria and things. And so it just it rotted the roots right off the trees, killed the trees, just poisoned them. The guy thought he was doing a good job, see? And this happens a lot. I watch people, especially with heavy clay soils, wanting to dig compost down deep. Don't do it. Leave the stuff where it's at. That's where it belongs. It works fine. The clay's great right where it is. Do your work on top. If you have a clay soil, you got drainage problems, work up. Don't dig down. By piling the compost on top of the soil, and allowing the plants to be growing literally above in a larger aerobic zone, and then growing down into the clay that's beneath as far as they can, you're going to have a much healthier plant. It's just going to work out so much better. But even in sand soils, apply the stuff on the top, because on the top is where all the evaporation is going on with sand. And so if you cover the top with a good coating of slashings from your bushes, cuttings from your flower garden, weeds from the yard, whatever it is you've got, expensive MacNut compost, whatever, doesn't matter. Pile it on top. Pile it on top. That's where it belongs. Now, as far as fertilizers are concerned, sometimes fertilizers in dry climates need to be dug in a little bit further so that they stay moist, active, and the plants can reach them. When there's a low rainfall, fertilizers need to go deeper into the soil. Where it's a high rainfall, they need to go higher in the soil. Simple rule. More rain you get, the higher your fertilizer goes. No matter where you live, keep the organic matter in the top 4 to 6 inches. Don't go below that. Leave the native soil that's down there. If the soil is hard, difficult to work with, then when you dig the hole to put the tomato in or whatever it is, when you get to the bottom of the hole, take a spading fork, put it in the hole, pull, put it in, pull, fracture that stuff. Fracture the clay. Fracture the hard compacted soil below. Leave cracks in it by ripping at it some, so the roots can penetrate, so water can go down, so air will get in there, worms will crawl in, and so forth. Don't try to take it out of the hole. This is a real bad idea. Leave it right where it's at, but break it up some. Breaking it up is the solution to the problem. Put all the good stuff on the top of it. With the sand, well, you don't need to worry about the compaction much. Again, stuff goes on the top. With the silt, you're sort of halfway in between. Silt soils tend to breathe better, and so organic matter can go deeper in them than it does in clay. The same with sand. Sand breathes even better than silt, and so the better air moves through the soil, the deeper the organic matter can go. Now, I don't want to get too complicated. but that is the way it works. Right? Don't ever put organic matter where air can't get to it. That's not a good plan. Well, as far as horror stories on replacement of soil go, here's one, and it's real. I saw it firsthand. City where I lived in California, they had compost facilities going on, taking all the municipal yard waste and things, composting them, and then they have these giveaways, and so people run out and they get that free compost. Well, a lot of people are really drawn to that. Now, you could not get me to touch that stuff with a 10-foot pole. My suggestion was to use it in the city park, use it on the freeway clover leaves, use it somewhere, but don't put it in my yard, because the compost from municipal waste is loaded with all sorts of problems. They'll throw anything in there, and it's a problem for the people who handle the waste, but a lot of it gets ground up. The biggest concerns are that the majority of plant material that gets thrown in there, like from dead trees and things like that, well, to begin with, they're oftentimes infested with various pathogens. You can have Fusarium in there, you can have Phytophthora in there, you have Verticillium can be in the debris that comes from diseased trees, and these things will transmit. They won't always be killed in the composting. So you kind of can inoculate your yard with pathogens that you never had before when you're using that if the compost wasn't perfect. But that's questionable, because if the compost was really hot, it should have killed most of that, all right? But the worst part of this is people like to use weed and feed fertilizers on their lawns. And a good portion of what goes in those green waste bins is grass clippings. Well, if they throw weed and feed out there on the lawn, it kills the dandelions. The guy comes through and he mows the lawn for them and throws all the clippings in the green waste bin. Well, grass clippings haven't got a lot of volume to them, a lot of nitrogen, but they're much carbon and they're not much volume. And when they start to heat up in a compost heap, you probably end up with less than a 20th of what you actually had previously in volume, because they just break down to almost nothing. But the chemicals from the broadleaf weed and feeds don't break down under heat. And so you've concentrated the chemical, is basically what's happened, to lethal and insane levels. Now, this is not my information. I originally learned this from Rodale Press, the organic gardening people. They've studied this a lot, and so don't have to take it from me. Check with Rodale. They know about the problems with broadleaf toxicities, all right? This is the worst case scenario of where it can go when you cop a bad attitude about your soil. I am telling you, love that dirt in your backyard. If you don't love that dirt in your backyard, get out there right now, get down your hands and knees, and you kiss the ground. You got to learn to love your soil, because all soils are good. If you have a sand soil, you don't have to worry about mud. There's no such thing as mud in the sand soil. You don't have to worry about root rot. You can dig this stuff anytime it isn't frozen, you know? Really, your only issue is you got to keep water. So there's your bad issue, water and nutrients. And so how do you hold water and nutrients? Organic matter. And so if you have a sandy loam soil that has a high percentage of silt in it, well, and you don't like it, you don't need horticultural advice. You need a hedge shrinker, because you got the perfect soil on earth. Really, that's a good scenario. And so I don't hear no complaining out of you guys that own that good sandy loam, okay? You got a soil that's predominantly silt, which is what I had in California. It can get a little hard during summer drought, you know, but it's a good soil. Solutions are similar to with sandy soils. It's a little more organic matter, you know, and again, with a silt soil, which it can become somewhat compacted if it has enough clay in the mix. When you're digging a hole, make sure you score the sides of the hole. Some guys dig square holes because it allows the roots to penetrate at the corners. I used to take a spading fork, jam it in the sides, kind of crack to make fissures in it. Don't leave a nice, slick, smooth area. That goes for silt or clay soils when you're digging the holes. Nice, slick, smooth side from the shovel is a bad thing. Roots hit it and they just turn. Okay. So make sure that you get the sides of your holes scored. You get to the bottom of the hole. If things look a little dense down there, and sometimes they do, again, fracture. All right? Fracture. If you got a clay soil and you got an attitude towards it, well, I really don't blame you, because if you don't approach the clay soil just right, it can be pretty problematic. And so it does perplex a lot of gardeners. But the solution, again, is not only more organic matter, but the solution is also don't hate the soil. All soils have positive things about them. The clay holds more moisture and more nutrients than any other soil on earth. Nutrients and moisture are what make plants grow. By and large, problems in clay soils most of the time are here, not there or in the plant. Okay, the plants, most of them don't mind much. Okay, there are rules. You know, you plant high in clay soils. Always plant high. Plant up, don't plant down. You plant down in a hole, things are going to rot, you know. Build things up when you're working with clay soils. Fracture, and especially on all sorts of soils. Use cover crops. Use green manure. I know this is an ancient technique. You know, it goes back to the beginning of time. Original farmers used weeds as green manure. As time developed and we had seed production, then they began to use alfalfa or rye, you know, or vetch or field peas or fava beans or sun hemp, or, you know, there's so many things you can use as cover crops. Mustard. You know, as we developed, we realized that we didn't want the weeds seeding in the field. So instead, we'd plant our own weeds, and then we'd, you know, plow them in or mow them and lay them down. Generally, I mow and lay down here. I don't turn anything in. In our soils here in Hawaii, because, as you saw on my shovel, it's soft. We get a lot of rain. If I get that stuff beat up like whipping cream and I go, oh, look at that, it's nice and fluffy, how beautiful, and we got one of them 6-foot rainfalls, that stuff moves. I have seen thousands of pounds of soil move around this property in the past with rain if they didn't have roots and organic matter in them to bind them. My rototiller that I brought from California is over here in the shade making rust because it just doesn't work here. If you till the soil up, the rain just destroys it. And so we keep everything covered. We keep roots in the soils. I plant into the dead roots of other plants. So we go crop, cover crop, crop, cover crop, cover crop. The cover crop usually gets laid down around the crop as it's being planted. I even grow stick mulching plants like pigeon peas. And so as my crop is growing and maybe I got little weeds underneath, I'll prune the pigeon peas and lay all the pigeon peas down as mulch on top of the soil. Organic matter is mostly the solution to most of your problems with soils. Cover crops are one of the wonderful solutions. If you live in a place like most of the mainland states where alfalfa grows well, use it. It has a deep taproot. It'll pull nutrients from way down deep. It fixes 1,500 pounds of nitrogen per acre. We sell it in bags as fertilizer, you know. So in closing, I appeal to you. See the good that's in your soil. Learn to love your soil. All your soils are good. There are no bad soils out there. There are only bad farmers and bad gardeners. Because a good gardener can take any kind of soil and make it grow a crop. Now, if you're as lucky as I have been to end up with what is some of the better soil on the island of Hawaii, well, it's cool. But we don't all have that. So you do the best with what you got. Aloha. Malama de Aina.